We have a right triangle. One leg is exactly 13 units long. And here's the important part. All three sides of the triangle are positive whole numbers. Our mission is to find the exact area of the triangle. Let's assign some variables. The vertical leg is 13. We'll call the horizontal base B. And we'll call the hypotenuse C. Since this is a right triangle, the Pythagorean theorem immediately gives us 13 squared plus b squared equals c squared. 13 squared is 169, so our equation becomes 169 plus b squared equals c squared. Now let's rearrange it. Move b squared to the other side. That gives us 169 equals c squared minus b squared. And that right side should look familiar. It's a difference of two squares. So we can factor it as the quantity c plus b times the quantity c minus b equals 169. Now comes the clever part. Since both b and c are positive integers, both of these factors must also be positive integers. And because c plus b is obviously larger than c minus b, we just need two positive factors of 169 where the larger one comes first. Let's list the possibilities. 169 factors into 1 times 169, or 13 times 13. Can the factors both be 13? No. If c plus b and c minus b were both 13, they'd be equal. But c plus b must always be greater than c minus b, so that case is impossible. That leaves only one possibility. C plus b equals 169, and c minus b equals 1. Now everything falls into place. Add the two equations together. The positive b and negative b cancel instantly, leaving us with 2c equals 170. So c equals 85. Now substitute that into c minus b equals 1. 85 minus b equals 1. So b equals 84. Look at what we found. The triangle's three sides are 13, 84, and 85, one of the most famous Pythagorean triples. Now, for the easiest part, the area of a triangle is 1/2 times base times height. So the area is 1/2 times 84 times 13. Half of 84 is 42, and 42 times 13 is 546. Therefore, the exact area of the triangle is 546 square units. If you enjoy clever geometry and logic puzzles like this one, don't forget to subscribe. I'll see you in the next video.